Today's video is an introduction to functions. Before we talk about functions, we have to introduce some vocabulary so then we can properly introduce functions. So the first word we're going to talk about, we call the domain. And the domain is the set. Another word for set is like a list. Okay. The set of all first elements of ordered pairs. Ordered pairs being a keyword here. Another word for the domain items we can call the inputs. And in math, in an ordered pair, the x value is the x coordinate is a member or an element of the domain. The other vocabulary that we need to be introduced to is called the range. And the range is the set or list of all second elements of ordered pairs. Because I'm running out of ink for this. Another word is the output. And in math, the second number in an ordered pair is the y coordinate. It's a member of the range. So it's important to know these words and what these words mean. Now, before we talk about functions, we should really talk about what a relation is. Not relationship, but the two words are kind of related. Okay? A relation between two sets. So we're looking at two distinct sets between two sets of ordered pairs. So order matters. Of ordered pairs. I really have to get new markers. My apologies. Of ordered pairs from each, but containing one object from each set. So relation between two sets of ordered pairs containing, I'm gonna have to throw this marker away, containing one object from each set. So relation, you're dealing with two sets containing one object from each set. So a perfect example of a relation in math is a coordinate pair where the first value is an object of the first set, the domain or input, and the second value is an object from the second set, which is the range. So a input, and this is its output assigned to this input. That's an example of a relation. Now there are many examples of relations. I'm going to erase now. Many examples of relations in real life. Like, for example, my height and age. My age would be my domain, let's say I'm 37 years old, and my output would be my height. I'm 5 feet tall. So this is an example of a relation between two sets of an ordered pair, where order matters, containing one object from each set. Now a function, now we can get to the actual definition of a function. A function is a specific type of relation. So let's pull that vocabulary down. Function is a specific relation, not just any relation. Okay, a specific relation such that every input, in other words, every element of the domain, the first set, every input is assigned exactly one output. And typically in algebra class, we're given a relation, and we want to find out, prove whether that relation that's given is a function or not. So let's do an example. Here's a relation. Oops, I forget that doesn't work anymore. I gotta throw it away. Here's a relation, and this particular relation that we're gonna look at as a list represented by a list of coordinate points. So here's a collection of these points. Okay, and I'm gonna first point in a quarter pair. The first point is always an element of the domain. So in other words, your x. And the second point is your y. Okay. So this particular relation is a collection of these 4 points that contain an element from each of the two sets, the domain and the range. And we are being asked, is this relation a function? So the first thing I'm going to do, I'm going to just show my work, kind of when you show you my thinking process. Step 1, I'm going to list out the elements in my domain that is being used and the elements in my range. So all my domain items in a coordinate pair are the first elements, the first values in an order pair. So I have a 1, I have a 3, I have a 4, and I have a 5. All these values are numbers in the set of my domain. Domain are my x values, also called my input. I'm going to list out now all the values in the set of my range. That should be a better set notation, sorry. Okay. The 2 is the only value being used in my range. Now, notice that this particular 2 is assigned multiple times for different input values, but I'm not going to do this because they're all the same number. I'm not going to repeat the values when I'm writing out the list. The list is just telling me what value we have in the set of the range. We have 2. It's all the same number, so we don't repeat. Now, one of these were, let's say, a -2, then I would have to make sure that I list out the value of -2 because they're not the same number, they're opposites. But in this case, the only value in the range is 2. Although it's being used multiple times, it's still the same number, so we don't repeat. So now we're going to move on to step 2, and we're going to create a function map to see whether this relation is a function or not. Okay, and we start out with our 2 bubbles that represent, the first bubble represents the set of my domain, and the second bubble represents the set of my range. And what I did in step 1 is I'm going to put into vertically into my bubble. So this bubble represents all of the elements in the domain for this relation. And then I'm going to do the same thing. I'm going to put the 2. This is the only element in the range. As you can see, I'm not repeating, just like I don't repeat in step 1. And then I'm going to draw arrows, and the arrows represent each the relation between the x and y elements for each point. So when the 1 is inputted, 2 is assigned. As I can see, when x is 1, 2, y is 2. So I'm going to draw an arrow that says input 1 is assigned output 2. Then I'm going to look at the second point, the second corner pair here, and I see that input 3 is assigned to output y. So that's going to be represented by this arrow. Then I look at the fourth point in my relation, input 4 is assigned output 2. And then I look at the last point in my relation, input 5 is assigned output 2. There are 4 relations. Well, this relation has 4 pairs, so there should be 4 arrows. One may look at this and be tempted to think it is not a function because they're misinterpreting the definition. They are misinterpreting the definition because they see that the output 2 is assigned multiple inputs, and they think, oh, it's not a function. But if you look carefully at the actual definition of a function, we don't really care about how many inputs is assigned to an output. All we care is that all the inputs, every single one of the inputs, is assigned exactly 1 output. So if we check, 1 is assigned only 1 output, 3 is assigned only 1 output, 4 is assigned only 1 output, 5 is assigned only 1 output. It doesn't matter that they're all assigned to the same output. What matters is that every element in the domain is assigned exactly 1 output. Therefore, for step 3, yes, this relation is a function. Because every input is assigned only or exactly 1 output. Let's do another example. So this time I'm gonna have a table. Let's put a blue table, and this relation, it's a table. Now some people you'll see it xy, sometimes you'll see x f of x, and f of x is just another notation for y. It's only supposed to be used for function, to be honest with you. That f of x means it's the y or the range of a function, but in this case we have to decide whether this is truly a function or not. Let me do different colors. So first we're gonna do the same. We're gonna do what we did earlier. We're gonna do step one. We're gonna list out all the elements in the set of the domain. So I accidentally switched to colors, but okay. So I see that 3 is one element in the set of my domain. -3 as well, and I have to list it because they're not the same number. And then 2. I see that 2 is used 2 times, but it's the same number, so I'm not going to repeat it. If I do that, I'm going to make an error, a big mistake, and we don't want that. Then I'm going to list out the elements in the range. We have 5, -1, 4, and 2. I'm going to list them all because they're all different numbers, so nothing repeats. So now I'm going to go ahead and create my function map. The first ball is always going to be my input, or my x, and the second is always going to be my output, my y, or my f of x, another name for output. I'm going to list out step 1, and I'm going to list out step 2. I should probably make this a bigger circle. Okay, it's kind of hard to see, I apologize. And I'm going to look at each pair. Notice there's this first pair, second pair, third pair, fourth pair. X is always the input in my machine. When I input 3 in this relation, 5 is the output, so it's my first arrow. When I input -3 into my function or my relation, -1 comes out. When I input 2, the output 4 comes out. When I input 2, the output 2 comes out. Now, if you look carefully, -3 has exactly 1 output, as represented by the 1 arrow coming out of -3 goes to -1. The +3 has exactly 1 output. The input 3 is assigned 1 output, as represented by the 1 arrow coming out from 3. However, notice that the input +2, the orange 2, has 2 outputs, as represented by the 2 arrows. Input 2 is assigned 2 outputs, 2 and 4. So because of this one input item, this relation fails to be a function. So we say step 3, no, it's not a function. Because you could say because not every input is assigned exactly 1 output, because the key word is here every and only 1 output. Or you could say it this way, because input input 2, this one, is assigned 2 outputs, or is not assigned exactly 1 output. So far we did 2 examples where we looked at a relation, a set of points, and the other example we looked at is a table. And through this process of the function map, we were able to clearly see that this relation is not a function, because not every input is assigned exactly 1 output. Okay, hopefully this was a good review of functions. Take care.